Hi, welcome to this Math Skills Q&A session on performance. My name is Ben Weiss. I'm an engineer on the Android Developer Relations team, focusing on performance. We've assembled an expert panel on performance, and we'll answer your questions that you ask on Twitter or in the YouTube comments before this session. Also, while we're streaming, feel free to use the chat. We'll answer your questions as we go. Now, I'd quickly like the panelists to introduce themselves, starting with Carmen, right next to me.
Thank you. I'm Carmen. I'm an engineer on the Android platform performance team here at Google, and I have a special interest in focus on app performance. So that's what I think about all day. You might remember me from last year's Mad Skills series on performance. So thank you so much for having me here today. Tomáš?
Hi, everyone. My name is Tomáš Mlynarič, and I work as an engineer on Android Developer Relations team at Google. Since Carmen was mentioning where you could see her, you could see me in this series of performance from Mad Skills. Next, Chris.
Hey, I'm Chris. I work on the Android Jetpack performance team, working on tools like benchmarks, baseline profiles, things like that.
Welcome, everyone. I'm really excited that we're having this session, and there are some questions that we have lined up, and I think we can just get going with it. The first question, and I think it's a good question to get started with, is, well, where should I get started when working with performance?
Hey, apologies for any background noise. Can you guys hear that? I apologize. When you get started working on performance, or does someone else want to take that while I?
Yeah, a good place to get started on performance is tracing. Specifically, system tracing in Studio is a really great way to dive into just what's going on in your app broadly. You can see things like frames, jank, and you can kind of inspect your app's startup time from a very high level, see multiple threads. That's a really great place to get started. If you're a bigger app and you want to kind of invest in the space, another great place to look at it is in continuous integration with tools like benchmarks. Those are great places to look. And I think also baseline profiles, we'll get to that probably in just a moment.
And also, I'll add, just if you don't want to do, like, if you cannot do any work, you can maybe check just logcat and see some bits of information like time to initial display. You'll see the startup or time to full display. You'll see, you can see even some information about jank, like if your app skips any frames or something like that. So if you're not sure if there's any problem or something, or if you just want to start to see some information without any work, you can check logcat. Otherwise, the traces, as Chris was mentioning.
Carmen, what would you recommend to get started with performance?
Yeah, absolutely. I totally agree with what the others have said. What I would generally recommend is to start taking Perfetto traces and really start to understand how what's in the trace relates to what's happening in your app. You know, so making sure that everything that's in the trace, you know what each piece of work means, what it's doing, that it's doing what you want to be doing at that time. You know, that, for example, during app startup, you can account for everything that you see in the trace, and that those are all things that you need to have happen in your app startup critical path. So just as one example, but that kind of generalizes to any other place where you want to do performance testing. Take a look at your Perfetto trace, make sure you're really happy with everything that you see happening there.
That's a lot of info already. I really love it. There's one thing that I would like to say is there's a lot of keywords, a lot of libraries, tools that we already mentioned. I would recommend if you want to get started, you go to our developer documentation, theandroid.com/performance, where we have a lot more guidance exactly on this. Also, we have 2 video series. One of them is the Math Skills on performance that we just did now. The other one is the one that Carmen did, where she goes in depth on a lot of the performance debugging, using Perfetto, using assist traits, using Android Studio tools that are available, a lot of those things. Also, well, you're at the right place. If you want to get started, or if you have more advanced questions, now is the right time to ask those questions. And I think we've got more questions lined up. So let's just get going with the next one, which is, well, in a video, we mentioned that OpenGL render and the choreographer tags. I'm new to the subject. How can I learn more about this? I think that was a video that Thomas made, and this is about logcat. Thomas, do you want to talk about this?
Yeah. So as I was mentioning, like right now, so logcat actually gives you some information about performance without doing any work, any job. So, for example, if if the UI is janky and skips some frames, you can filter logcat with the OpenGL render tag, and you'll see that how many frames or how long it took. The jank took actually. There are other tags as well. So the choreographer tag the choreographer tag will tell you how many skipped frames there were, meaning that's like a slow rendering, and the OpenGL render tag will tell you if it was even longer. That we call it like a frozen frame. So that's definitely what your users could see. Besides these two, you can also filter activity task manager tag, which will tell you about app startup. So time to initial display, that is when the first frame was shown of your app. And also you can filter with the same tag, time to full display, which is when your users can actually interact with your application. So filter, you can check these 4 tags to get some information about performance.
Awesome. Thank you. And generally, logcat, if you haven't used it, well, you probably should. It's ADB logcat if you're using on the shell, or in Android Studio, you can open that up. We recently overhauled the way that logcat looks in Android Studio, so it's a lot easier to filter. You can save your filters as well. You can share filters with other people in your team, and I also recommend just playing around with it and seeing what sort of tags you see, and then going, for example, to a Stack Overflow or asking us on Twitter, because, well, we're here. We want to hear what you want to know. We also have documentation logcat on several tags, not everything, because things like there's a lot that gets logged. But yeah, just play around with your app and see what's happening and see what tags you deem useful. The next question we have is on admob. It's from David Oakley from Twitter. It's, hi, admob is our slowest part of a app startup on the main thread. Is there anything you can do to improve the response time?
I can speak to that somewhat. I'm not very familiar with the admob API specifically, but generally speaking, if you have some kind of asynchronous request like that in your startup, the performance move will be to move that out of the critical path. So if you can set up your startup flow so that admob's queries or whatever are happening in a separate thread, and then your UI is updated later when that response comes back. So for example, you could set up your UI to allocate the space for the ad that you want to show, but maybe leave it empty, have the admob request for the ad running in the background rather than blocking your startup, and then fill in the hole that you left for the ad when the request comes back. That will probably be the best move to let your startup continue to flow quickly and hopefully kind of smoothly without having to wait for admob or deal with admob's variable response times. And that would apply honestly to any kind of asynchronous request like that during startup, not just admob, but anything like that where you're requesting data and getting it back. It would be ideal to not wait to show your first frame or your UI until that request comes back. Instead, start to populate, show a loading spinner or something if you have to while you wait for that information.
I think lazy loading is a great concept for that, and using that in this case is awesome. We also have a library when it comes to initialization when you have content providers and you want to have more structured initialization, which is the app startup library. And that basically gives you a possibility to say, start this after something else has happened, and making sure that stuff doesn't just get launched unstructuredly, but you have the possibility to say, like, one thing has to start after another, and that gives you a performance boost by structuring the startup as well.
But yeah, in general, when you want to improve startup, so kind of be lazy, lazy load as much as possible what you don't need to be in the critical path of the startup, and you can postpone, then you should do that so that the startup is better.
We do have more questions, and I want to go through them so we get a chance to answer most of those burning things that we have that you had on your mind. One of the questions that we got is also around baseline profiles. So what are they, and how do they improve performance?
So
I can go ahead, Chris. Yeah.
Okay. Baseline profiles are a way for you to skip the initial part of your app's performance being poor because it starts out with jitting. It starts out by interpreting code, jitting dynamically as it's needed. And while Android will improve this over time because your app can get compiled in the background, the hot methods will be compiled for the next launch. That information is unfortunately thrown away every time that your app is updated or restarted. Anytime it's updated is updated or installed from scratch. So baseline profiles give you a way to tell the installation process through play and through art that, hey, these methods are important. This is a critical part of my startup. This is a critical part of like my main user flow through my app. So let's compile the hot methods during those, and it can increase startup performance by 40% that we've seen in the real world, which is kind of big.
Yeah, so just to tag on to that, that first day of app performance when your app is not compiled yet, and it's running the JIT and running the interpreter as you use it, that first day, the performance can be significantly worse, 40% or so. And that will last until the profiles that you've collected during those runs are able to be compiled in the background while your phone is idle. So usually that would happen, say, overnight while your phone is plugged in, next to your bed, and just sitting there overnight. But sometimes it can take a day or two before your phone is in that idle situation. So baseline profiles let you start out in the compiled state rather than needing to learn what to compile over the first day. So rather than having the worst performance on the first day, your users can have their already compiled performance starting from the very beginning, first day that they use the app.
And there's two different types of baseline profiles as well. There's the baseline profiles that libraries can provide for you. So one of these that's really important is Compose. Compose, as an unbundled UI toolkit, has a lot of code that isn't in the framework that would by default not be compiled. But as long as you're using a recent version of AGP, of Android Gradle plugin, 2.3 or 7.3 or higher, which is currently in RC, then you can get the methods that Compose deems to be important for performance pre-compiled at installation time. You don't have to do anything, just update to the latest version of Android Gradle plugin. The other version of this is that you can define your own custom profiles. You can say, well, I want to have not just library code, but my own code for my own application be included in that and be compiled at install time. So what you can do for that is you can create a macro benchmark, which allows you to run through the various key points of your app that you want to be pre-compiled and generate baseline profiles for that. We have a guide on that. You can look on d.android.com for baseline profiles. That will generally result in significantly higher performance because it can hit more of your specific scenarios and your specific code.
Yeah, hitting that app startup code for your own particular app is where we get a lot of that 30 to 40% improvement. Library code does help. It, especially with library code, a lot of times where we see that improvement is with jank and smoothness, when so that the library code doesn't need to run on the interpreter, get compiled really fast as you scroll the page or quickly load new, images or new code in kind of a frame time limited situation.
I want to add maybe a thing, because we're saying that it helps with the jitting, with the just-in-time compilation. And maybe a question would be why there is jitting, right? Why we chose to just-in-time do things when we could pre-compile everything, right? That's what actually is happening on older devices, on Android Marshmallow and Lollipop, right? Back then, all of the apps were fully pre-compiled. But we figure out there are some downsides with that either the applications are taking more space in memory, they are taking longer to actually load. So that's why we chose the path with the jitting, that the startup is actually better than fully pre-compiled applications.
Yeah, baseline profile is a true hybrid between what we've been doing for the past few years, which is jitting and background compilation, plus the best parts of ahead of time compilation back in those older versions of Android.
So as you can see, there's a lot going on with baseline profiles. We deem it really important. That's why we talk about it a lot. And I think it is really important. And if you don't use it just yet within your app, it's totally worth checking it out because you can quickly use it with macro benchmark, get started creating your own baseline profile, and we're also continuously improving it. I have a question from Colin M. Lee from Twitter saying, we use app bundles, but baseline profiles require an Android Gradle plugin, a beta version. Is the tool chain going stable anytime soon?
I can try to answer. So in general, we don't provide exact days, exact dates when something is going out and is stable. The reason is maybe like one reason not to disappoint you, obviously. But we can say that the Android Gradle plugin is actually in RC, in RC1. So we consider that very stable. You can try to use it, but for the stable release, you need to wait a little bit more.
Yeah, but I agree. RC means release candidate, and all the bugs that we have found should be fixed at this point. Everything should be fine, and that is where we deem this to go stable very soon with one of the next release cycles. And if you know how the release cycles work, they are on a regular cadence, and expect this to happen soon. Unless there is somebody that hasn't used them before, starts using baseline profiles now, uses the AGP, finds a bug in there, and then has to go through another version, and that would be RC2. But we don't really expect that to happen at this point. But nonetheless, it might. We do have questions from YouTube, which is awesome. So I want to go a bit quick detour from the pre-recorded questions that we had and go for a question from YouTube from Zeus. When an app starts, there's a black screen appearing for a while until time to initial display. There's no work being done in onCreate. Could this be because of Compose?
Ooh, that's an open-ended question. I would say, go ahead, Chris.
Oh, I was going to say, by default, until your application draws its actual first frame, the background drawable, I think, in your activity that you're launching into defines that. There's, gosh, it's been a while since I've touched this stuff, but it might just be that you're missing a drawable to show your default screen. And you may have swapped this out if you're trying to switch from views to Compose. So take a look at that. Make sure that you're using a background drawable that's defined in your.
Yeah, there's an API that we released last year for showing an animation as part of your app startup. And so take a look at that API. I think I don't know if anyone knows the exact name, but it's something really. It's like Android startup application. Or Android startup
splash screen.
Splash screen, yes.
Splash screen, yes.
Yeah.
Yes. So take a look at what you're doing with the splash screen. Try replacing it with something you like better than the black screen, and see if that's just what's going on there.
Yeah, that's definitely right. Good things to do. And also, if those two things don't really help you, use the profilers, see what's going on in there, so you can see and pinpoint exactly where this is happening. And if, for the worst case, this actually is part of not the implementation that you have within your app, but part of Compose, please let us know, because we want to make sure that these things get fixed, which is also one of the really cool things about Compose. It is an unbundled framework. It's an unbundled UI framework. So if you find a bug, you report it, the team can very quickly fix it and roll it out, not just forward for a future UI, for future versions of Android, but also backwards down to where the versions are available for all devices. We do have more questions. There's a couple from YouTube, but I'd like to pick one from the pre-recorded right now. From Nitin, does a cloud profile work for, oh, sorry, that's the wrong one. Nitin asked a couple of questions. So how can we reliably measure the improvement promised by baseline profiles? Chris, you said that we saw improvements of up to 40%. So can you say something about how we can measure this?
Yeah, absolutely. So the easiest way to measure this locally is by using the macro benchmark library. It just went stable fairly recently, and it allows you to define a test that, say, opens up your app and measure it using different compilation modes. You can say, what's the default compilation if there's no pre-compilation? What's the startup time that I get? What's the startup time that I get if I use baseline profiles? You can even compare it against full AOT compilation and see that probably that number is going to be slower, because, as was mentioned before, that's more code to load from disk as you're starting up. So macro benchmark makes it really easy to just define a block of code that that say launches into your app, and if you like to navigate through it for different scenarios like flinging and scrolling. We have samples up on GitHub.
And I will add maybe more, like that's definitely where you could start with measuring the improvements. But also you can then, if you're, for example, not seeing improvements with baseline profiles, you can check the system trace, and you can actually check for the, I think it's called JIT thread pool thread. And you would see like if the just-in-time compiler is actually doing any work or not. So if there's not any work and you're using baseline profiles, that's probably working well. If you see some work or a lot of work there, then probably there's something wrong happening with the baseline profile. Maybe it's not applied properly or something like that. So in general, well, when the compilation mode is none, you're not using anything precompiled, there should be a lot of work in this thread. You would see a lot of traces there. But for the partial or precompiled, you would see like minimum amount of work there. So that's like when you're not sure as a next step.
Awesome. We had another question from Nitin, which is about cloud profiles. So would a cloud profile work for an app that updates every 2 weeks? I think we quickly covered that in the beginning, but maybe you can talk a little bit more about the times here.
Yeah, so the answer is kind of yes and no. The cloud profile collection process still runs, and that process is as we use the app, the profiles of as your users use the app collectively, the profiles of their use are collected and uploaded to the Play Store and aggregated for cloud profiles. That process takes a long time because for cloud profiles, we choose them specifically for different device and API combinations, and we need to have a certain amount of them aggregated before we release that cloud profile to the users again through the Play Store. And that amount of time can take over a week. I think it depends on how many users your app has, how fast they jump on that new release. But even for pretty big apps, we see it taking a week or more. So while it might work, and after a week of your app's release, or maybe a week and a half, you would start to see your users would start to see those cloud profiles being shipped with their app being downloaded. Ultimately, on a 2-week release cadence, you would likely only see a few days of that really benefiting your users before you drop a new APK and the cycle has to start over.
Cool. Thank you so much. So let's go ahead and take another one from YouTube. We've got another question from Miri Hago. When do we need instrumentation tests regarding performance? Always?
Do I get to choose? Always. When do you need them? That really varies depending on your app and what's important to you. I would say pretty much every app could benefit from a startup test. If your startup time regresses, you would want to know, right? So instrumentation tests, I'm kind of combining that with like a continuous integration concept where you run those tests, something has changed, you can become aware of it. It's such a bummer to release a new version of the app and see from your field metrics after it's already out the door that the performance has degraded. So I would say almost any app can benefit from a startup instrumentation test. Other areas of your app that might be performance sensitive are going to vary with your app. And I understand that there can be a lot of complexity in setting up tests. Seeding your devices with realistic data and stuff like that. So while I feel like you should always performance test, maybe sometimes that's the way you want to do that might depend on how your company is set up and how what resources you have. But I would say every app deserves some instrumentation tests.
I agree. Every app. Sorry.
No.
I agree that we have that it makes sense to have automated tests and automate your app is the testing not just for performance but also for general UI and instrumentation tests and integration tests. For some apps, they're not at that stage yet, and they want to experiment and figure out like what stage should I be doing this in. And we have split our guidance on performance into 3 different pillars, which is inspect, improve, and monitor. Well, instrumentation tests can be part of every single one of those sections, but you should totally have it for inspecting in order to see like what's going on for startup, like Carmen said, for also frame timing and these things, but also for monitoring, because you can see whether your changes actually made a difference. We talked about this throughout the series, but also I think, Thomas, you talked about when you like how you get there from not using automated stuff yet. So I think that's what you were going for.
Yeah. I wanted to mention that having the tests as part of your CI pipeline is super nice, and in general you would like to have that, but that really depends on the performance team, how big it is, if you have time for that, because usually you have to ship features before performance, right? But what I want to say is that with, for example, the macro benchmark library, it's super easy to set those up with the template in Android Studio. So just create a new module, add a simple test, and it's really easy to start up, to use and measure some performance on your real device to get some numbers. You can then keep the tests in the source control in your source code, and from time to time, if you don't have the performance team, from time to time just run the test to see if the startup, for example, doesn't regress, and if it is, then you can check it. So I would recommend like doing it even if you don't have the performance team, just setting it up, trying get the number, get the feeling like what's in the startup path, and it, because it's really easy to get started with it.
Yeah, one thing I'll add to that is another great time to do that interactive testing is anytime you're adding something significant to your app. Maybe you're swapping out your ad network, or you're doing some significant new feature that adds a lot of UI to your app. Those are great times to just check and make sure that startup isn't regressing. And in addition to being much faster to iterate that way in terms of how quickly you'll see measurements versus the field, the other big advantage is that it just comes with a trace out of the box. You can click through and you can understand a lot more about what happened, and it's kind of hard to get at some of that data in the field if you don't have a lot of infrastructure around getting detailed trace metrics.
So in general, always.
That's a nice end for this question. But also one of those things when you automate stuff is you get the possibility to, well, write more code. And Christian Wertner from YouTube had a question that I think is very fitting for this. I have a screen that should be included in a baseline profile. It's behind a login wall. Are there any ways to navigate to that screen?
Yeah, so there are two main ways to do this. One of them is to just use UI Automator to navigate through your app by actually typing in say a test account username and password, going through that flow through the app itself. This also probably has the nice benefit of also making sure that login screen experience is optimized for those new users that are signing up as well, and that's performant if it has animations, for example. The other way to do this that's a little bit more advanced is to have a different variant of your app that has an additional broadcast receiver. So one thing that you can do is you can have a broadcast receiver that is added to that is added to your app only in this testing environment, which will allow it to receive information from the benchmark that will say like, hey, log in with this username and password, or initialize with this data file. That's another more advanced way to do it. That can get you kind of to the same goal, but that requires having a different variant because you probably don't want to ship that broadcast receiver in your public release build.
Cool. Thanks for that. Thanks for the question, Christian. I know that I answered it on the comments as well, but I think it's good to call that out because it's definitely a very valid and use case that happens every now and then. So it's good that we talk about it here as well. Moving on to the next question before we pick another one from live from Twitter, we've got one that is from Amshreyas Patil. How do you generate a baseline profile from CI or CD? So CI is continuous integration, CD continuous deployment. So from continuous integration, I think is the right term in this case. So anyone would like to answer this one?
I think that this is like in general, in as big as abstraction as we can, we'll try to explain, because that would cover like several steps. But in general, you would to generate the baseline profiles on CI, you need to set up the generators same way as locally. You write the tests that would actually generate the baseline profile. Then on your CI, you can use the Gradle managed devices we explained in the performance in the MathScale series to actually run the tests on a emulator. So you don't need to set up the emulator or anything; it will do it for you, and basically it will generate the baseline profile as you defined it. Then in the pipeline, you probably need to have a step or something like that that will copy the generated file, the generated baseline profile, into the source/main folder. And then the last step, what you actually need to do is build your application with the generated profile. So basically what will happen is that first you'll build the application, the benchmark variant that will generate the profile, but then you need to actually again build the production application that you will ship to your users. Then there can be an optional step. If you wish, you could actually copy the generated folder as a commit to your version control so that you can merge it and have it there for next time. But that's like an optional step. So did I forget anything? I'm not sure.
No. Sounds about right.
Yeah.
Let's pick another one from YouTube. Thanks for the answer. I think Java Jafari had a question. Should we use multiple profile for different ABIs?
Oh, that's a great question. So the nice answer is you don't have to. These profiles are basically lists of information about references to your DEX file. So they're all just telling Art, hey, here are the bits of this DEX file that are important. All the compilation stuff happens on device. So the reference to a DEX method that is not yet compiled to something like, say, x86 or ARM is valid for both of those architectures and will get compiled on either architecture just fine.
Yeah, and in particular, it's kind of cool if you look at the human readable baseline profile file that's generated through this process, you'll see that it's literally a list of kind of classes and methods with annotations and so forth. But it's pretty readable, and it's just the methods, the code that is being used. So yeah, converting that to compile for the different ABIs, as Chris said, it happens later on.
Yeah, and just to clarify, that's the human readable format. The format in your APK has essentially the same data, but it is, much, much smaller and much more efficient because it is, using offsets and so on.
Yeah, it's like by much, much smaller, this is like a very efficient packing algorithm, and the way that this gets compressed is very impressive. So totally worth calling out that it's not the stuff that you see in the human readable format. If you want to see the compiled one, pick your app bundler or your APK, throw it into Android Studio, which will open the APK analyzer. And then you find the baseline profile file, which is just the baseline prof, not the prof m. And the prof file is basically what you're looking at. This is the file size that can't exceed 1.5 megabytes. We briefly talked about the Gradle managed devices, and there is a question on the YouTube comments from Nyan. Anyone else facing this? The task Pixel 2 API 30 benchmark Android test not found in Project Benchmark. I think this was on one of the videos that you made, Thomas.
Yeah. Yeah, sure. So this task is like completed out of several things. Like the Pixel 2 API 30 is not like a random thing. This is a task that would be created by the Gradle managed devices, which is a feature of Android Gradle plugin that comes with the 7.3.0, which we said is RC now. So the reason why you're not seeing this task is maybe potentially that you use the older version of Android Gradle plugin, like 7.2 something. So that may be like the obvious reason to. So you could basically update. You need to update the Android Gradle plugin so that the task is generated for you. Yeah, I think that would be mostly the case.
Cool, thank you. And Gradle managed devices are the best way that we've seen to, well, create your app, to run the emulator and set it up, tear it down on your CI as well. So that's an easy way to do that, because all you have to do is declare it in your Gradle script and your build Gradle file. And we do all the rest for you with downloading the emulator, cleaning things up, launching it, and shutting it down afterwards. We've got some questions from YouTube. I'm sorry if we don't get to every single one of those, but let's pick another one from there. From Ashkai. Akshay is, I'm a library developer, which for a library which many apps use. What should I do? Any starting docs? So what you should do, I think the thing that we've been talking about a lot is baseline profiles. And including a baseline profile in your library is a possibility for you as well, similar to including a file that does the sorry, I'm blanking right now. Similar to a file for your consumers of your files that does stripping out of ProGuard. Oh, thank you very much. I was blanking on that one. That does the ProGuard files as well. I think Chris will be back in a second, unless he just said, like, Ben doesn't really know his ProGuard anymore, I'm leaving this. He should be back in a second. But so similar to that, you can also ship your to your users. You can ship the ship a baseline profile, which is a human readable format, which also libraries like Compose do, which several other first-party libraries of of Android do, which we've seen other libraries outside of the Android X teams do already as well. And you ship your library with your baseline profile. You basically have to create a sample application, which creates the baseline profile, and then you ship that as part of your library release. And with that shipped library, you then give your users the benefit of a newly created baseline profile, which then gives your users the possibility to have a faster application, which is awesome. So that's the one thing that you totally should be doing. Documentation for that is available on theandroid.com/performance, and you should totally do that as the first thing. Obviously, there's other things, a library developer, making sure that stuff is properly inspected, that you lazily load things, and other things like that. But if you want to spend little time and have a big gain for all of the users of your library, baseline profiles is the thing that I would recommend to do.
Yeah, totally agree. Oh, go ahead, Tomáš, and then.
No, I just want to mention that this is exactly what Compose does, and basically all of the Android X libraries, are shipping with the generated baseline profiles rules, so that all of the consumers, all of the apps are getting the benefit of it.
Yeah, and just to add to that, 100% agree. Baseline profiles is probably the first and most impactful thing that you can do. Thank you, by the way, for being a library developer, for doing the work to help out probably many other apps. Another big thing that I would say I always hope that library developers do is to set up representative instrumentation tests, so that representing the user journeys that you expect your apps to use, the types of things that you're aware of that your apps use, and keep close tabs on the performance of those critical pathways that your user apps are relying on. So I think basically that continuous integration tests are extra important for libraries, because app developers are relying on you, with great power comes great responsibility kind of thing, to maintain good performance for the library that you're creating. And to do that, I think the best way to do is to kind of write a sample app that exercises the kind of key parts of your library and kind of tests those things, as much as you can in a simple sample app, using some of the tools that we already have provided for continuous integration testing, like macro benchmark, for example.
And I'll add more thing to that, is that we mentioned macro benchmark library several times, but for a library developers, we also, it's not just for the library developers, but we have also a different benchmarking library, which is called micro benchmark. And this library is a little bit different, that you actually can measure the CPU of the code you execute. So if you're a library developer, this might benefit you as well, depending what your library is doing. But let's say you're doing some CPU heavy image handling or something like that. So for that, you can actually set up the micro benchmark library and measure if the algorithms you use are actually performing well, and improve and iterate on that. So in addition to macro benchmark library, to using like the user journeys you anticipate your consumers of the library will use, the clients of the library use, you can also use and set up the micro benchmarks so that you can measure exactly the algorithms in your library, and making sure these are performing well as well.
Yeah, for example, in I hope you can hear me. For example, in Jetpack, we have many such micro benchmarks for everything from compose to navigation to room. But basically, if anything is CPU bound, something that is processing a lot of data, great to write a micro benchmark of it, whether you're a library or application developer. It can also be helpful for an application developer to say compare libraries in places where performance is critical for, like, say, processing data.
Absolutely. Also, Chris, I'm glad you're back. I thought you rage quitted because I didn't remember ProGuard and the files that we're doing there, and that you can ship those with libraries as well. So welcome back. I think it's a good end to this question, which there's a lot of things that we can do for libraries and library developers, things that we're doing with an Android X as well. We are library developers on that end as well. So if you have questions, if you see things that are unclear, also ask us. We're here, not just here right now, but also on Twitter, on our issue tracker, on Stack Overflow. We like look at all the sources and try and figure out what's going on and what things you need to make your libraries better as well. I think we can move on to the next question, which is from Twitter, from Olivier Perez. Why does the profiler disconnect sometimes when I'm trying to find what is overusing the main thread?
I don't know if any of us are specifically profiler experts. I assume you're talking about Android Studio Profiler, and it can be slow sometimes, especially when kind of doing computationally intensive things. I would start by saying there are some. If you're trying to find what is overusing the main thread, I assume you're using some of the CPU profiler tools that we have in Android Profiler or in Studio Profiler, and there's a few of them. Some of them are more effective than others, and those actually tend to be the faster, more efficient ones. Some of them are actually less effective debugging tools, and they also correspond to be the ones that are harder to use. So in particular, in Studio Profiler, I recommend using system tracing and pprof. I can't remember if that's what it's called in Profiler, but the two.
The method sampling is, yeah, it's been renamed recently for clarity. Is that what you're talking about?
Yes, yeah.
Okay. Yeah.
So yes,
now.
System tracing and method sampling. Both of those are a little bit more lightweight in terms of collecting the information from the area that you're interested in. If you're using method tracing, or I think there's another one that's basically also just method tracing, maybe it's Java method tracing. Those are collecting stack samples at the beginning and end of every single method that's called, which is really heavyweight. Method sampling does the stack samples at a specific rate, which usually still gets you the information that you need in terms of understanding the proportion of calls that are in one stack versus another. But it's a little bit more lightweight, probably a little bit less likely to disconnect the profiler. So I would say my first thought for this question is to make sure you're using system tracing and method sampling instead of the other two tools.
So I do want to also interject. By the way, if you have a bug with the profiler, please try the latest version. And if it doesn't work, if you have something reproducible, please file a bug. We're happy to look at it. Also, I would say I kind of look at this a little bit differently from Carmen. I think where I think method tracing is valid, but it's less of a performance tool and almost more of a debugging tool. Like, it's so intrusive and it can make your app so much slower to start up. But if you really want to know, this thing is slow, I have a stack trace that tells me that it's slow. Why is it slow? Well, sometimes if you want to know, say, it's because it's calling this other method beneath it 50 times every time that it's being called, sampling won't tell you that, method tracing will. You just have to deal with the fact that you're throwing away all the timing information while you're looking at it. So, different ways to look at the same kind of space and get different types of data out of it.
That's absolutely right, and that's a great call out as well. Even sampling profiling, I wouldn't call that really including the timing information. When to take a kind of a step back from this question, when you're performance debugging, I would always recommend starting with system tracing. Right, if you use system tracing, you'll be able to see the kind of actually accurate timings of how long did each thing take. Then once you know which timing you don't like, then you can dig into what's happening during that particular segment, maybe using one of these other tools to figure out why that's happening. So I would definitely recommend starting with systrace, looking at the trace, seeing what's taking the most time, and then potentially digging into some of these method sampling tools or other tools like logcat, honestly, or just anything that you can use, adding trace points to figure out what's going on and what's taking up the most time in those critical periods that you're concerned about.
I really like emphasizing. Oh yeah, go ahead.
Just go ahead.
Well, I really like your point about emphasizing specifically adding trace points, because we're all used to a lot of code bases that have had people doing tracing in them for a very long time. But if your app doesn't have that, then it's a really great way to get started, is to say, hey, my startup is slow. What's happening in, say this big chunk? Well, you can add tracing around initializing this library or loading or around your image loader if it doesn't already have that. And you can suddenly make your trace significantly more usable and commit that code. Leave that in so that over time, you can get more and more data and more just kind of intuitive answers to your performance questions of, oh, why is this slow? Oh, well, it's because we're loading an image synchronously here or something along those lines. You can have that data just available to you immediately, just kind of by building that up over time.
Yes, absolutely. And on top of that, sometimes these method samplings or kind of stack sampling strategies may or may not be stack sampling all of the different processes that your app might be communicating with to do what you're trying to do, right? If you're calling out to some other process or service, and that process or service is doing a lot of work and taking a lot of time, you'll see that in your trace that you're waiting for that response, but you might not see that in a method sampling that's only looking at the methods that your app is calling. So you can get kind of skewed results if you assume that those correlate with timing.
This is a great gist of the series that you did on this topic, which is several videos. It takes a long time to fully go through that topic. And I've seen on the chat now, there's some people going, oh, I'm newbie on this. And this is absolutely fine. We want to help you going from I've got no idea what this is, and we want to also demystify this. And we want you to be at the point where you're comfortable with the things that we're talking about. And this is why we have the documentation. This is why we have those videos out there. And this is why we have the possibility for you to ask all those questions. And I'm really happy that we have all of you here to actually being able to answer that, because there's so much going on, so many things that are super helpful. And I think the main thing right now from all of this is, if timing is wrong, make sure you do the right thing. Go system tracing, get the timing data out of there, do tracing yourself, add your trace points which also has a Jetpack library, which gives you more possibilities to do tracing. If you want to do it within a single file or a single method, you can do things there. Also, Firebase performance monitoring, you can do tracing remote as well, which reports that into the Firebase console. There's a lot of ways that you can do things. We talked about these things in detail as well in the series that we just released in the Mad Skills series. And those are things that well, you see that we're all very passionate about these, but there's more questions. So we, in the sake of time, I think we should just continue for a little bit. One of them, I think it's about compose from Javad from the chat here. A side key, what improves lazy columns performance? I think because this is Compose and we are all not directly integrated, working with Compose, this is for the Compose people that are working on Compose performance, which we have another Ben that works on this from the DevRel side, and we have quite a few people from the engineering side that work on that. So I don't really feel comfortable answering how do you improve Compose performance. Does anybody else feel like we should talk about this?
I remember one advice, I think it was Simona at IO giving advice on performance with lazy layout, and that is that you shouldn't have like the zero-sized items, which is, for example, you have a composable, which is a image or something that loads from network, and until the image is loaded, basically the size of the image is 0. And this tends to have a performance impact on the layout as well, because first it's laid out with the zero-sized items, which may spawn so many items that basically it doesn't work as a lazy layout anymore. And then when the images are loading, it basically will recompose every time the image is loaded, and then move to the items out of the screen and suddenly working as a lazy layout. So make sure that whenever you have something like that, you either use a placeholder or you set the size of the image or of the item so that it doesn't go like on the screen up and down, and so it actually works as a lazy layout. But that's the only advice I would give.
Before we dismiss this, since I mentioned Ben Trengrove, he works on this and he wrote an article recently. And also we have documentation on the performance there, on things that you can do and should do in order to make performance your app perform well when using Compose. One of those things, we've heard people say, well, Compose is kind of a bit slow and janky when I use it in debug. That is one of the main things. Always test your stuff for performance with release builds, because debug builds add a lot of overhead. They add a lot of things that allow you to inspect things, that allow you to debug, to set breakpoints, to make sure that you actually get the possibility to play around while things are going. But if you consider saying, if you have something on a bench, like if you were to have an engine, a regular car engine on a benchmark and have it plugged into a lot of things, that performs way different than if it was in a car that actually does all those things. It's the same thing than if you have that with an application. If that application is wired up to your debugger or to your profilers, it will perform slower and will perform differently to what your users are seeing. So make sure to test on a real device, make sure to test the release build, and those will perform a lot better than things that you see in debuggable builds. That's general advice.
Yeah, this is exactly why both the Android Studio profiler, or at least system trace, as well as macro benchmark will kind of warn you or complain at you if you try and use a debuggable build. They're very, very far off from accurate measurements.
Yes. So make sure to read this. Make sure to read the documentation on Compose performance. Make sure to follow the series that we have, all the things that we will soon come out as well on Compose performance. Kind of foreshadowing here already, but those are important things to keep in mind. Also, running a release build on a real device, that makes a lot of sense, because otherwise you will get data that is not just right. We have more questions from YouTube. Nayan asked, Android Studio slows down when performing Java method trace on a low-end device. That's not phrased as a question, but I think we can still answer that. I hope.
Yeah, I think this is pretty similar to the previous question. I will say, when we're doing those method traces, we're dumping the stack a lot. And that's extra work we're asking that low-end device to do. So it kind of makes sense. Especially on a low-end device, it's probably using most of its power to do whatever you're trying to do. So adding all that extra work to take all those stack samples, or to dump all those stacks, is going to slow down what's going on, slow down the perception of it as we collect all that data. I don't know that there's much we can do about that.
I mean, I think we highlighted a lot of this before with the contrasting of the different tools of, here are the other tools, here's the different ways that you can trade them off. But
yeah, make sure that you're, when you are doing method tracing, that's kind of the ideal tool for the job. Taking a Perfetto trace should be a lot more lightweight. Both Android Studio and especially that device should be able to handle taking a Perfetto trace no problem. You'll have those accurate time measurements and use that to guide. Maybe if you are leaning on tracing a little bit more, maybe you'll have to use the method tracing, which is harder to collect, a little bit less. It's kind of what I'm thinking here.
And Thank you so much for that. That's a lot of different tools again. I think also for having a single device, that's always a bit tricky when it comes like this is a specific device where it's very low powered. Sometimes, well, you might have to try it with a different device if the error. I know that each device is different, and they also some error can come up on one device, it doesn't come up on another device. So that's kind of the ambiguity on some of those very detailed and minute things. Maybe just run a micro benchmark on the specific thing that you think that might be wrong and get the data out of that as well. So we have those different tools available, not just because we want to crank out a lot of tools, but because we think they're useful, because we think they help you to inspect your performance and make sure that the things that you're looking at actually give you viable and reliable data. Can we move on to the next question? I think that's another from the YouTube live chat, which is from Tanvi, which is baseline profiles gives an error that app startup is not in the primary DEX. How do I fix that? I would say generally the best way to fix things that problems like these are updating to the latest version of Android Gradle plugin, the profile installer, the micro benchmark library, making sure that you use what's going on the latest things there, because I haven't seen an issue like this in quite a while. I know that we had a couple of random things like that during the alpha and beta states, but that's why we have those phases. That's why we have, especially for a thing like baseline profiles, where a lot of different things come together, we have a very long phase to make sure that issues like these get settled. If you still see this after you update it to the RC of Android Cradle plugin, to the latest version of the profile installer, and maybe regenerate it, well, I don't think that it's the regeneration of the macro benchmark with the baseline profile itself, then please file a bug very urgently, because we don't want this to be a problem that other people see after we go stable.
And I want to just mention that we had some known issues with baseline profiles, and especially with the older versions of Android Gradle plugin, and the known issues are listed in the documentations. We will try to update them whenever there is a known issue we already work on and we know about. I remember there was a problem with multi-DEX apps and baseline profiles, but I think, and I'm not sure here, that we already fixed it in the newer version of Android Gradle plugin. So
yeah, I think that was 7.2, yeah. And 7.3 had APK bundles or app bundles, sorry, as well as the newer versions of the platform support for it's S plus, right?
Mm-hmm. So please try to use the newer Android Gradle plugin, and if it still is happening, please file a bug. We'll happily take a look at it and fix it as soon as possible.
There's a lot more questions. There's more questions coming in on the live chat, and we only have a couple of minutes left. So I'm very sorry that we won't get to all of those. I think we're nearing the time when we say this is our last question, which is from Mehdi, which is if there's one thing that you could recommend an Android developer who's 100% new to performance to improve their performance, what would that be?
I'm so torn. Baseline profiles is something that you can implement without knowing much about performance in general. We have obviously been talking that to death. Super easy, improves your first day performance significantly, so on and so forth. Y'all have heard it 100 times at this point. But for someone who is trying to learn more about performance, is taking this on as like, this is something I want to think about long term, I would recommend taking system traces, using either system tracing tool in Android Studio Profilers or in Perfetto. And like I mentioned before, really getting to know exactly what is happening at all stages of your app startup, all stages of your performance sensitive areas. And you can really just ease into that, look at the trace, match up the pieces that are in the trace with what you know is happening. Every app, when they do this for the first time, they find some things going on that they didn't expect to be happening. So you'll certainly discover something new. I'd start there, dig in, add more traces to your app, become really familiar with exactly what your app is doing and when, then go from there.
And also you can just write a simple macro benchmark that will measure startup time or gives you information about Jenk. I know you were saying just one thing, and we're like giving you tons things. But these are the options, basically.
I mean, interestingly, macro benchmark is kind of right in between those two, right? Of like, it gives you traces, it helps you use the same exact test infrastructure that you would for setting up baseline profiles. So it can kind of, go right in between there.
Yeah, set up a macro benchmark test of your app startup. You get some kind of continuous results of how that changes. You can look at the traces at any time to see what has changed. The macro benchmark setup is a pretty nice setup and makes it very easy to do performance testing and take traces for a device that's specifically set up for this purpose. So it'll catch you if you try to run the tests in debuggable mode, or will make sure that your app is compiled in the way you expect it, or in the way it should be compiled for performance, and so on. So macro benchmark is a great way to start collecting traces and data in a really nice kind of secure, I guess, knowing you're doing the right thing, security kind of way.
Trustworthy, yeah.
Trustworthy, yeah, there we go.
Well, there's a lot of technical stuff that we just talked about in this. I think I think that is important is also none of us were the experts that we are today from the beginning. Just take the time that it takes you to get going with these things. Take one thing that you think is a big problem for your app, get started with that, and slowly ease your way into that. We're trying to make this more approachable. We have done this over the course of this year and before then as well, with the libraries and all those things that we have out there to make sure that things get easier for you. Go to our developer documentation. Make sure to check out what's going on in there. This should be giving you a guide that takes you through a structured approach to inspecting, improving, and monitoring your app's performance. Also, library performance, obviously. While the main focus is on apps, we will also have more guidance for libraries and potential other areas as well in the future there. Make sure to ask questions. Like this is a great question, because asking questions will give you answers, and these answers can help you to make things better and to slowly get into the point where you can also help other people out. I think those are very important things as well, just there to try and figure out how things are going well or not so good with your application and use the data to improve your app's performance. There's one last thing that, one last question that we have in here before we actually wrap this up, and that is, thanks, from Tomáš Mlynarič on the YouTube comment. Thanks. Can you provide more episodes of Mad Skills? Mad Skills is an ongoing series. So that means that we have had a couple of skills already on performance already, 2 seasons, one of them featuring Carmen, another one featuring Tomáš and me. We have been working together with quite a lot of people to make sure that those give you all the information that you need. We will continue to make more. There's another one, I believe, on Compose coming out fairly soon, which will give you some more information detail as well. There might be somebody talking about Compose performance there as well. And there's, like as you heard, there's a lot to talk about performance. And those are all the questions that we could answer today, unfortunately. But we've got loads and loads of content, and we want to make sure that you get answers to the questions that you have. So make sure to check out the stuff that we have out there, which is the developer guidance, which has best practices, code labs, samples, documentation, articles, videos, all around performance. Also, reach out to us on Twitter, on the issue tracker, so we can help you to make your apps and libraries perform better. So, and before I close off, I just want to say I hope that you enjoyed our performance today, and thank you very much for coming here, and goodbye.